Hello everybody, thank you for checking out my video. We are currently this semester calling this unit 7, but regardless, it's the 4th day of the rationals unit. And on this day, we're adding and subtracting rational expressions, very similar to how in elementary school you might have done, for example, 1/3 plus 3/4, where you have to find a common denominator, like 12. And the way you get 12 is if you times this side by 4, but if you multiply the denominator by 4 to keep things even, you have to multiply the numerator by 4. But on this side, it would be multiplying by 3, which would be 9 over 12. And now that the denominators are the same, I can add them, getting 13 over 12 as an improper fraction. Remember, the denominator doesn't add. So my first example was really simple. The denominators are the same. I can add them simply combining. I'm adding the 6x and the x to get 7x. The -8 and the 3 gives me -5. And again, the denominator simply stays the same. But of course, it's not always going to be that easy. Our denominators are not always going to be the same. I did this example in class, but I'm going to do this different example for here in the video. So looking at the denominators, not only are they different, they're very different. So what we can do is everybody's favorite thing to do in this unit, we can factor this one, and I'm hoping what's going to happen is they'll be more similar in terms of talking about the two denominators. So two factors of -21 that will add up to -4. -7 and 3, I'm sorry. So like that, I've got this x plus 3 over here, and I've got an x plus 3 on this side, so my denominators actually are more of the same now. They're way more similar. This side simply needs an x minus 7 to make the denominators the same. And just like we did in 3rd grade, if I'm going to multiply the bottom, I have to multiply the top, aka denominator and numerator. Note that x minus 7 will multiply with the entire numerator. When I do that multiplication, I'm going to need the box method or FOIL method if you're good at that, or there's maybe a few other ways that teachers have taught you in the past. But in terms of being organized, this is definitely helpful to do it this way. X times x is x squared. I got a -7x, a positive 7x, and a -49, which will go back together and make just the x squared minus 49 as these two cancel. You might have noticed it looks like the end of a difference of squares problem, and it was a difference of squares. Now to finish, all I need to do is subtract, because there's a subtract here. I need to subtract the 3x. Now sometimes we have work to do on this side, but our denominator didn't need anything else. -3x doesn't mix with anything, so final answer is x squared minus 3x minus 49 over the x minus 7 and x plus 3. A couple things about this though, the sheet that I'll give you will ask you for the a, the b, and the c of your numerator. That's a 1 for a, -3 for b, -49 for c. And also note that the bottom, the denominator is in factored form and the numerator is in standard form, which I personally thought was an issue the first time, but this is how the EOC leaves it. So that's how I'm going to leave it. Be sure to, when you work problems from my page, be sure to check the bottom. The next one that I'm going to do, this is the one I did in class, and the EOC will give it to you, like, as far as the A, B, and C goes, they'll have drag and drop, so you can, like, just pick the one that you need. So ideally, when I worked the first one in class, I got one of these numbers, and I did get 13. And in the middle, I got -43, and at the end, I got another -13. So just because I don't want to do the same example in class, here, making another example, and I actually think that I can do one of these. I can just kind of throw some numbers out, and it's going to work. Because all I'm doing is trying to add them. I'm not like solving it or anything. I'm not worried about getting a decimal. So I'm going to add these together, and I'm looking for the numbers that come out in my numerator. So here goes. First question, are my denominators the same? Nope, so I can't add them. Can I factor to maybe make them look more the same? Nope, they're both first degree x's, no GCFs, no difference of squares. So I'm going to try to get a common denominator, and I'm going to multiply this side by 2x plus 3. What I do in the denominator, I'm going to do in the numerator. And hopefully you already know what I'm going to multiply on the right side. Right side, I'm going to multiply, by x minus 5. So though it looks like I have a lot of work to do, I understand the denominator is already finished. The denominator is 2x plus 3 and x minus 5. So it actually kind of looks a lot better if I go ahead and clear out all that denominator. Nope. When I do those multipliers here, it multiplies with the entire numerator. Same thing over here. The way I've written it, looks like just the -4 is distributing, but again, I'm trying to multiply that times the whole numerator. So I technically need to make it look like that. So I got to do box method again because I'm doing 2x plus 3 and 2x plus 5. And by the way, just to make it a better example, I saw a lot of kids mess this part up in class. I'm going to go back and change it to a subtraction problem. And the reason I'm doing it is just because, again, I think I already did a couple plus sign ones, and I saw some kids mess this up today. So let me go ahead and finish this side. 2x times 2x is 4x squared, then a 6x, and then a 10x, and a 15. Remember, if things are set up correctly and you do the work correctly, these two are going to combine as like terms, giving me a final on this side of 4x squared plus 16x plus 15. And whatever I get, I'm going to subtract all this other stuff I get over here. So one of the issues I've saw is sometimes kids will often try to go ahead and distribute this negative to the 3x, but that negative is going to go to the entirety of this side. I'd rather go ahead and simplify it rather than try to worry about where exactly to put that negative right now. So I gotta do 3x minus 4 times x minus 5, which is 3x squared minus 4x minus 15x and plus 16. By the way, when I go fast, I'll make a mistake every semester at some point. I just think I generally make 2 mistakes on that every semester. Just take your time. It's tedious work. It's lengthy. It's not difficult. So this is what I got from the box method. And again, everything I got from over here is going to be affected by this negative. So that negative is going to turn that 3x squared into negative. It's going to turn that negative 19x into positive 19x. It's going to turn that 60 back to negative 60. And finally, I'm 99% done, as I seem to love to say. All I got to do is combine my like terms, and I got it. 4x squared is going to combine with negative 3x squared to make x squared, as in 1x squared. So hey, my A is 1. 16x, definitely want a highlighter. 16x is going to combine with 19x. I believe that is 35 x's. And last but not least, 15 is going to combine with negative 60 to make negative 45. My A is 1, that invisible 1 you don't see right there. My B is 35, and my C is negative 45. So definitely the longest problems that we've done this year. Not necessarily the most difficult. Appreciate you watching.